Hello again, this is Point on Pally back for another video, and today what we're going to go over is building a rigging setup for a animation loop for a walk cycle. Now what I mean by that is we'll show you what it's doing. So if I turn this on, you'll see we have a walking animation loop that has multiple aspects of control. I can control the speed of it. I can control the distance of the path. I can control the height. And I can control the offset, meaning its initial position of the animation. So I can actually control where the animation begins. Now, this idea came from my other video series, Making a Character Rig. And in that video, I have a character that doesn't actually have any legs. It has 13 tentacles at the base of its body. And I wanted to set up those tentacles so that it could walk. And as I was rigging those tentacles, I had thought, man, wouldn't it be very convenient if there was some type of animation loop that we could do so that an animator doesn't have to animate or key all 13 tentacles. So that's kind of where the idea came from. And through a number of tests, this was the kind of the best option that I came up with. And you can see from the video that's displaying here that it came out pretty well, and you can get a pretty decent animation. What I was kind of going for there was the Dean Hardscrabble character from Monsters University, trying to mimic something like that. And so what we'll do in this video is we'll go over how the setup actually works and the creation of that setup. And before we go any further, yes, this does work with a biped character with an RFL setup. You can actually integrate the RFL controls into this setup, as you can see by the video being displayed here. So with that, I can actually show you how this is all working. So if I go into the controls group here and unhide all this, you can see kind of what we're working with here. So this setup all starts with a NURB circle. And connected to this NURB circle is a locator. And it's connected via a motion path, only on the translates. We don't really have to worry about the rotates. And this locator is set up to move only with the top half of this circle. Now, through a series of node connections that we'll get into, it cuts off halfway through the circle. With this setup, it's obviously connected to the pad of this control. And with this, we can also connect some squash handles. This controls the height and length of the circle here. So with any control here, we can actually increase the length or the height. And the way the speed is connected here, it's run through an animation loop on the motion path's U value here. So the motion path is what connects the locator to the circle, and the U value is, for those unfamiliar, the U value essentially is the distance that the object connected to the circle, it refers to, it gives like an animation loop of the locator going through the entire path from the first CV to the last CV. So it's a 0 to 1 value. And what I have set up is an expression that will cycle through this U value from a 0 to 1 based on the frame number. So as the frame goes, it'll increment a value on the U value here, and it'll cycle through that. So once it gets to 1, it'll go back to 0. And we'll go through the setup of all of that and how to do that. Now, the last thing you might have seen on the control is the offset. Well, how does that control this? Well, the animation path goes from the first CV over here, the first CV right here, and it goes through it goes through from the first CV to the last CV. That's how the motion path works. Well, what we can do is actually, it's kind of a little bit of a workaround, but we can actually rotate the control, and it actually it rotates the CVs. So that first CV moves with the rotation. And the good thing is that the rotation doesn't affect the squash handles or how they work. So the rotation adheres to the squash handle setup, so it'll work out with everything here. So that's how the offset kind of works there. So that's what you see, this control here is actually controlling where the first CV and basically the start of the motion path begins. So with all that, now we can go into the actual setup process. All right, so we have the ant rig here. This is just the primitive rig. This is without all the animation loop stuff. So this is where we'll get started. And we'll start by doing this same, the setup just for this first control here. And then I'll kind of fast forward to having the rest of them done, and we'll go from there. So to start with, I'm just going to hide the main, the character in the rig and all that. Then we'll just kind of leave this open so that we can go through the initial process of building the setup. So the first thing we want to do is to build the NURB circle. So I'm going to create NURB's primitive circle. And what I'm going to do in this case is just bring this up to about 90 degrees here. Let's freeze transforms on it. Now, you can add sections if you want. It really doesn't make that much of a difference. It'll just, like if you add like 48 sections here, it'll just fill out the circle just a little bit more, but there really isn't that much of a difference here. It'll still be pretty smooth the whole way around. So I just like having the more sections on the circle, the better for me at least. The other thing I want to do is to check where that first CV is. So it looks like it's over here. So what I'm going to do is I'm just going to rotate it so the first CV is actually down here. And what this is going to do is going to set it up so that the start position is right here in the middle. And we'll get to explaining all that. So I'm actually going to take this, rotate it down 90 degrees, and then freeze transforms so that first CV is lining up right there at the bottom. Perfect. All right, so I'm going to delete history on them. So we get rid of those other nodes, and we'll just call this, since we're dealing with the first left leg, so we'll call this first left leg 1 path curve. All right, so next we're going to create the locator. So we go to create locator. There we go. Now you don't have to use the locator. You can use you can really use whatever you want. But I've always liked using locators. They're kind of this separate thing from joints and groups and all that. So I like to use locators when I can. So I'm going to call this left leg 1 path locator. So I give everything the path name just to let it know that that's what I'm working on. So at this point, what we can do is actually attach the locator to the curve. So I'm going to select the curve, shift click the locator, and we go under the rigging menu, we go to constrain, motion paths, attach to motion path. Now, you don't really need to mess with any of the options here. You really don't need to worry about any of the axes here what the world up type is. You don't need any of that because we're only we're only dealing in translates. We're not dealing in rotates, and that's what all of this stuff is dealing with right here. So you can just click attach, and that's fine. So the first thing I want to do is get rid of the rotates here because we actually don't need them. So I'm just going to break connections and 0 the rotates. Now you'll notice something that happens. You'll notice we're getting the cycle warning down here. Now, the reason for the cycle warning is something to do that happens when the motion path is created. And if I open the node editor here, clear this, you'll see what happens when I look at the locator. Not only here's the motion path, but it created these 3 add double linear nodes. And these nodes are the problem when it comes to the cycles that we're getting. So if I look at the motion path here, the first thing I want to do is get rid of this U value, because the U value is what I'm going to control the movement of this locator around the circle. So if I break connections, there we go. So now this U value can control the locator going around the curve. But I do want to get rid of these add double linear nodes because they create the cycle. And truth be told, you don't really need them. You can actually, all you really need to do is plug the coordinates attribute directly into the translates, and that works just fine. So you don't actually need the double linears, because you see how it's kind of creating that cycle. The locator is going into the double linear and it's going back into the locator. So that's where the cycles are coming from. But you can delete these and then just plug the coordinates back into the translates. Now I could just plug the main all coordinates right into the translates, but what I'm going to do is I'm going to plug these in separately. And for this, the main reason is that we're actually going to have an additional setup to control the Y coordinate there. But if I test it, it should still work all the same. Looks good. All right, so I'm going to name this real quick. There we go. So left leg 1 path, motion path, there we go. Now, you'll notice that when I played the finish setup, you notice that the locator kind of stopped midway through the circle. It went through the top of the circle and then stopped and went through the middle. So what I want to do is create a node setup that will essentially convert the Y coordinate here and cut it off midway through. So that's what we're going to do here. Now the first thing I want to do before I do that is I want to group these two things together. And this group is important. It's a key aspect of this setup. So I'm going to group everything together. I'm going to call this left leg 1 path pad. Pad is just another word for group for me. I always just learned it as I was always taught to use pad, so, and that kind of just stuck with me. I use group occasionally. Here's the way I kind of differentiate with the naming. Group I just use as a suffix for organizational purposes. So like these are just to organize. These don't serve any particular function like movement wise. Whereas if we get into the controls, then you can see I'm starting to use pad here because these are the pads for the icons and things like that. They actually require movement. So that's kind of the difference here. So this is actually going to dictate some movement, so I'm going to call it left leg 1 path pad. Now, really important thing is I want to turn on the path locator inherent transforms off. The reason why, if I move the pad right now, you see we get double transforms on that locator because it's following the pad itself and it's also following the motion path. So that's where you're getting the double transforms. So if I turn this off on the locator, then you can see it follows normally. So that's a really important thing. Make sure you turn inherent transforms off. All right, and since I created it, it's already showing up here, which is good because this is actually going to serve a function here. So what we're going to do is we're going to use a condition node to convert this y coordinate into the translate y of this locator. So we're going to create the condition node here. And we'll call this left, right, 1, path, condition. So what we're going to reference here is the y coordinate of the motion path. So I'll plug this into the first term. And for the second term, what we're actually going to use is the translate y of this pad here. Since this pad is going to be kind of the master control here, and this is going to dictate where we move everything in the scene, I want to use that translate y of the pad. I don't want to use it with the circle, since the circle is following the group. It's not going to have any translate y values on it. So I don't want to use the circle. I want to use the path pad here. So I'm actually going to plug the translate y into the second term of this condition. If I go into the attribute editor here, what I want to say that if the first term is greater than the second term, so if the y coordinate of the motion path is greater than the midpoint of the circle essentially, so if the y coordinate is greater than the translate y value of the pad here, then follow the motion path. But if it's not, I want it to stick on this flat plane, meaning I want to use this translate y value. So let's go through the connections. So if this first term is greater than the second term, I want to use the y coordinate for color if true r. And for color if true false, I want to use the translate y of the pad. There we go. So let's plug this into the translate y. So we'll go out color r into translate y, so to override the connections. Now you'll notice that when I did that, the locator snapped to the center here. So now, if I actually run the motion path, you'll notice what happens. So it goes through the normal motion path, and then it stops once it gets to the midpoint of the circle. And then it will actually come back to the origin point. And so that's going to give us this range of motion, this kind of walking range here, where it lifts up, goes to the top of the circle, and then comes back down, and then just slides on the floor. Exactly what we're looking for. So we've got the range of motion all set here. Now what we need to do is we need to set up the squash and stretch handles so that we can adjust the height and length range of this circle. So we can select the circle and we go to nonlinear or deform nonlinear squash, and we'll call this the height handle. So left leg 1, path, height, squash handle. And we're also going to do the same thing for the length. So we're going to select the circle, and again, we'll go to deform, nonlinear squash. Except this one, we'll rotate 90 degrees to the side. There we go. Make sure you don't freeze transforms or anything. I don't think you could even if you wanted to on the deform handles. So we'll call this left, leg 1, path, length, squash handle. So now we've got the two squash handles here. So if I increase the factor, it's now controlling these squash and stretch of the circle. Now the one thing that you're noticing when I stretch it, it's kind of thinning out here, which I don't necessarily want to do. I want to increase the height. I don't want to mess with the length. So the way we do that is with this expand attribute. If we turn this off, we turn it to 0, you see now the width or the length here is the same, but the height is increased. So it doesn't actually affect the length here, which is perfect. So let's do the same thing for the other one. Factor and turn the expand off. There we go. So we now have the ability to control the squash and stretch of the circle. Now let's parent these squash handles underneath the leg pad here. So now this pad should control everything. There we go. So the next phase is to build the animation expression that's going to control the entire animation loop setup here. So we're going to go to animation editors and expression editor. We'll call this, make sure we're filtered by expression name, left leg 1 half expression. Now what I need for this expression is the motion path name here. And we want .u value, since that's the attribute that's going to control the animation. Now, we're going to set this to follow the frame number. And what's going to control the looping animation here is the modulus operator, or the percentage symbol here. Now, what the modulus operator essentially means is it's the remainder of a division. So let's just say if I do frame number modulus 5, let's start with that. Just what that essentially means, it's going to take the frame number, which in this case is number 1, and it's dividing by a whole number or integer 5. And 1 divided by a whole number of 5 would return 0 with a remainder of 1. So essentially what it's going to return is the number 1. So if you go to the next frame, 2 modulus 5 would return 2. And it would keep going like this until you get to frame 5. So 5 modulus 5 would return 0 since there is no remainder. So the animation would actually loop back to 0 and then keep going again. So 6 modulus 5 would be 1 with a remainder of 1. So the remainder keeps looping this way. So that's where the modulus operator comes in handy here. Now, we're not going to be using the number 5 here. What the number you actually need is essentially the end of the animation, because we want to loop through an animation. Well, this u value here only goes to a max value of 1. So we want to use the modulus operator modulus 1. Now the problem here is that if you do the frame number modulus 1, it's going to return nothing but zeros, because every frame number divided by 1 returns a remainder of 0. So what we need to change here is we actually need to take the frame number here and divide it by a certain number. Now, this number that we're going to divide by is actually the essentially the length of time it's going to take to complete an animation. So if I were to do, put this in parentheses here, if I were to do frame divided by 48, this is essentially saying take the frame number, in this case, if I go back, take frame 1 and divide it by 48. What that'll get you is a really, really small value. And once you, it'll keep going. And once you get to frame 48, the 48 divided by 48 is 1. Modulus 1 will return 0. So this 48 number is essentially how many frames it will take to loop through that animation and go back to the beginning. And so this number here, we're going to make an adjustment here, but this is how we're going to control the speed of the looping animation. So if I hit create here, if I hit create and go back to frame 1, and I run the animation here, you see we're getting that looping effect. Let me up the frames here. So here's that looping effect. Now if I were to adjust the frame number here to something like 8, you're going to see it go ridiculously fast because it only needs 8 frames to make the loop. So yeah, going very fast here. And if I were to move this to like 120, it'll go much slower. So here's how we're going to control the speed. Now you'll also notice, if I bring it back to 48, that we're getting a slightly small value here. Now the reason for this value is we're not starting at frame 0, we're starting at frame 1. So that 1 divided by 48 is going to give you that really small value that I was talking about before. There is a way that we can actually get rid of that value, and we'll get to that once we actually set it up to control the speed. So at this point, we've got the animation set up. Now what we need to do is start connecting everything together to the leg control. So we're going to make everything visible again. So what I'm going to do is I'm going to bring this over to the control, or what would work easier if I select the control and then this pad, and I do a point constraint with maintain offset off in all axes, because I think I just had the one. Yep, so all axes, maintain offset off, there we go. And we'll delete that constraint. And there we go. So we got it in the position that we want. So now we can start creating some attributes. So I'm going to go to add attribute. Now the first thing I'm going to do is create the separator attribute, so we can kind of separate this from the main attributes. So I'll call this path controls. This is going to be an enum attribute. Let's take the blue option off, and I'm just going to convert this to a bunch of dashes. Once I do that and click OK, there's our separator. And at this point, I can just lock that. So that's how you create a separator attribute, just to kind of organize all your attributes. So, all right. So now we're going to need a few attributes. We're going to need an on-off attribute so that we can turn this on and off. We're going to need an attribute to control the speed, to control the height and the length, and to control the offset. So let's start with an on-off attribute. I'm going to use a Boolean. Now you don't necessarily have to use a Boolean attribute. I like them because they're just simple on-off switches. If you want to have kind of a smooth transition for your on-off, so it's not just a flick of a switch and it snaps to the off position, you can use just like a 0 to 10 float attribute and key it on and off so that you can get like a smooth transition if you want. So, but I'm just going to use the just a Boolean attribute for now. So we'll call this path on off. And we'll add that. There we go. So next we want the speed, so path speed, and we'll do, let's see, we'll do 0 to 10, something like that. Next we'll do path height, and this will be a -10 to +10 attribute. Same for the length. And lastly, we need an offset, which is also a -10 to +10. So we've got our attributes all set up. So let's start connecting everything together. So we'll go in order with the attributes. So the first thing I need to do is connect the control to the path control here. So what we want to do is constrain this control pad here. Now, what I want is to have it constrained to not only the locator, but I want to constrain it to a default, like just a generic pad right at its origin position, so that when it turns off, it goes straight to that original position. So what I'm going to do is I'm just going to take this leg control pad here, and I'm going to duplicate it. Delete the duplicate control underneath, and I'm just going to call this left leg 1 ref pad. So like ref means reference, so I just use that as kind of a reference pad. So it's in the exact same position as the control pads, so this will be like the default position. So at this point, I can select that pad and shift click the locator, and then command click the control pad here. And we're going to do a point constraint with maintain offset off, just like that. So now we've got the two aspects of the constraint that we will just simply key on and off. So I'm going to open up the set-driven key window here. I'm going to load the control into the driver and load the constraint into the driven. And we'll just key this on and off. So at off, this should be following only the reference pad. And we'll key those. Next, we'll switch the attribute. Always select the driver first, and then switch the driven. There we go. Alright, so on off, that's looking good. Alright, so next we can connect the speed in. So the way I'm going to connect the speed in is I'm actually going to connect this speed attribute to a separate node, and then I'm going to reference the node in the expression. So what I'm going to do is I'm going to open up the node editor here, clean it up, add this control, and the node I'm going to use is one of my favorite nodes, the set range node. So the set range node kind of functions almost like a set-driven key. It takes an existing range of values from the input, and you can adjust the animation range for the output. So I'm just going to call this left leg 1 path set range. And I'm going to take the path speed here and plug it into value x. I'm going to set the old min to 0, the old max to 10, since that's the range of the attribute. And we're going to set the minimum to really small value like 8. That was probably as fast as I could imagine the amp walking. And then we'll up the max value to something, a much larger value, something much slower. So we'll do 144, something like that. So at this point, I don't actually need to connect this node to anything. I just need to reference the node and the out value attribute. So in this case, out value x. Okay. Copy that. Let's take that name, and we'll go right back into the expression editor. So instead of the 48 number here, I'm just do set range dot out value x, and we'll create it. So it moved a little bit, but that's because the path speed is set to 0. So if I have to put like 3, you see it's probably going back to its original position, because that's about 48 frames, I'd say. Now, the other thing I might have mentioned is this really small U value here. How can we get it so that it starts with the U value at 0? Well, again, right now it is calculating the frame number, which is 1, and divided by the speed number. So it's still going to be a small value. What I want to do is actually subtract that value from itself. So what I'm going to do is keep all this information here, and then I'm going to subtract 1, and then I'm going to divide by this out value again, and plug this into the parentheses. So you see what happened there? Now the value is back at 0. So I took that really small value that you get from taking 1 and dividing 1 in the frame divided by that value, and I subtracted it basically by itself. And so that's how you get the default to start at 0 at the first frame. Now, if you're going to start at frame 0, you don't really need this extra step in here. But since my defaults to the starting at frame 1, this is how you would make sure that it starts at the original position here. All right, so with that, the expression is done. So we can close that window. And at this point, we have the height, the length, and the offset. We don't need any nodes for this, since this can all be done with basic step-driven keys. So we'll start with the height here. So I'm going to grab the squash handle. I'll actually bring in all 3 of the things that we're going to need to key. So the curve for the offset, and the height and length squash handles. So there are everything we need there. So let's load driver, and we'll just quick key everything. So we'll start with the height. So we'll just key, actually we don't need the handles, we need the actual squash nodes. So if I'm going to go into the node editor here, let me just quick map this out, and what we need are the actual squash calculation nodes here. This is where the attributes for the factor actually reside. So there's our factor attribute. So we just got to remember which one is which. So the squash 1 is for the height. So there we go. Squash 1 is for the height, and we've got the factor here. So we'll just key that. So we'll move this up to 10, and we'll move the squash factor up to, say, 1. We could go even higher. We could go 2 if we wanted to. And do something like that. So do 2, and we'll key it. And then we'll move this to -10, and we'll move the factor probably all the way down, something like that. And then we'll key it there. So now we've got the height all hooked up. Let's do the same thing for the length. Go through the same process here. Stick with 2, key it, -10, and move this all the way down. Key it. All right. So the last thing we need to key is the offset. So let me bring that circle back into the driven. So for the offset, remember we are going to be keying the rotation X of the circle itself, because that's what's moving the CVs around, and that's what's going to help us get our start position. So in this case, we'll probably rotate it, I'd say probably 180 degrees both ways, and that's how we'll key it. So we want to rotate X here. So we'll key it in its original position. So 10, and move this to 180. Key it. Move this to -10, and key it -180, so that we can offset at any point in the animation. Alright, so now we have an attribute to control the offset, so we can pick any position in this animation that we want to use. If you want to, you can go a little bit further with it. You can go to 360 if that makes you comfortable, but figured 180 to -180 gives us the full range of motion that we're looking for. And that's pretty much it at this point. So let's test it out just to make sure everything's working. So we've got the speed, bring it all the way down, it goes faster. Bring it all the way up, it goes slower. Let's check the height. Looks good. Let's check the length. Looking good. And and we already checked the offsets. We know everything's working there. So no matter where I set up the offset. Now you might notice something with the offset. This is something that you might notice once you're all done, is if I move the offset, so let's say if I were to move this to 5, 5 theoretically should put us right at the edge here. But as you can see, it's not doing that. It's going a little bit above it. And the reason for that is the default keying settings that we have for our set-driven key. Actually, make sure I turn the offset off here first. Oh, no, wait, it's off. Okay. Yeah, so if I get to 5, 5 should put us like right at the front point here, because 10 would put us at the top, so it's kind of going in quarters here. So 5 should definitely put us there, but you see we're at 3.9 and we're already at the front. And the reason for that, again, is the keying animation on the circle. Because if I go with the circle selected, if I go into Animation Editor, Graph Editor, you'll see this curve is on it's a smooth curve. So the values aren't going to be even here. So what we actually want to do is select the rotate here, and select the CVs, and we want to make the line linear so that it's just a straight keying value, so the numbers will line up. So now, if I hit 5 here, now 5 brings us to the very front point of the circle. So now everything should be working. So if I said -5, puts us to the end point of the circle. So that way your values for the offset are far more exact and precise. And there we go. So at this point, you would add the controls for the rest of the legs, and then you would adjust the values for them, the values for the offset, so that you have a unique animation like I showed you in the beginning of this video. And for frame of reference, yes, this can all be scripted out. Not a lot of what I did here was very complicated. And everything has a Python command in here. So yes, this can all be scripted out. So it can save you a lot of time doing this, to the point where you can just select the control and run the script, and it should make everything and have everything connected for you. So it can save you a lot of time. So yes, this can all be scripted out. So at this point, we can, since I've already shown you the finished product, we don't really need to go over that again. So at this point, we can go over how to set this up to work with an RFL setup on a biped character. So let's open that file and get started on that.